My people, how's it going? Welcome to Chapter 8. We're on pages 418 and 419 in your workbook. And we're going to start today with three-dimensional shapes. That's what Chapter 8 is all about. We're going to get into probably the hardest part of Chapter 8 right from the bat. So good news, it's all going to be easier than what it is after today. So today's all about surface area of 3D shapes. Sounds kind of confusing as it is, but remember guys, when we have a formula, write your formula out. We're going to plug in what we know, just like we did with the Pythagorean theorem. Anyway, here we go. Take it away. We should be on page 418, 419.
How are the areas of shapes used to find the surface area formulas for three-dimensional figures?
Yep.
Think about this question during the lesson. A contractor builds porch columns that are painted on all surfaces with a protective sealant. Each column is 14 feet tall and 2 feet in diameter.
Okay, dimensions.
If the contractor has enough sealant to cover 150 square feet, can he seal all the surfaces of one column?
I hope so. We're going to find out.
Draw a cylinder to represent the column.
Yep.
A cylinder is a three-dimensional figure with two parallel circular bases that are the same size. This cylinder's height is 14 feet, and the diameter of each of its two circular bases is 2 feet.
There we go.
How does knowing the area of a two-dimensional figure help you find the surface area of the column?
All right. So guys, when we find surface area, right, different than area we're dealing with two-dimensional figures. Surface area, we're dealing with three-dimensional figures, right? So we have to break these 3D figures out into what they call, I think they're nets, right? And you maybe talked about nets back in
draw nets.
5th and 6th grade and whatnot. So anyway, we have to come up with the nets for each one of these, right? Which in this case happens to be a circle and a rectangle, okay? So all we're really trying to do is find the area of the circle and the rectangle from this cylinder. Then we're going to add those two amounts together, right? That will be its surface area, okay? All right, so let's see what they do.
Draw a net of
I
the
just
cylinder.
talked about that.
The net of the cylinder
They're gonna draw it
includes
for us.
two circles for the two circular ends.
Top and bottom.
What other shape is part of the net?
Oh, I already gave it.
Select your answer.
I already gave it away. We know it's a rectangle. There we go. Sorry, guys.
The other part of the net is a rectangle wrapped around the column. Now we can use the net to find the area of each surface. Let's start with the two circles. They're identical.
Yep.
The area of one base is equal to pi times r squared,
That's the area of a circle.
where the radius is 1 foot, half the diameter. Use
Okay.
3 and 14/100ths for pi.
It tells me to in the
The area of one of the circles is about 3 and 14/100ths square feet.
Okay.
The formula for the area of the rectangle is area equals base times height.
Base times height, length
The
times
base,
width, same difference.
B, is tricky. It's the circumference of the circle. The circumference equals 2 times pi times the radius, r. The height, h, of the rectangle is the height of the cylinder.
We know that. Okay? So guys, a little bit confusing to try to remember all this. Again, two things to help you. One, that's why we have our handy-dandy formula sheet that's in your packet. Refer to that as much as you need to. And two, write the formula down and plug in what we know, right? They're always going to give us enough information to where we can plug in all of our numbers.
The surface area
Just
of
like
one
they did
column
there.
is the sum of the areas of two bases and the area of the rectangle. The surface area is about 94 and 2/10 square feet.
There you go.
The contractor has enough sealant to cover 150 square feet.
Do you have enough
So he
sealant?
can seal all the surfaces of one column.
You betcha.
And that's how you can use the areas of two-dimensional shapes to find the surface area of a three-dimensional cylinder.
Beautiful. Okay, so now it's our turn. Luckily, they're going to give us the formula here. At least I'm hoping that they give us the formula here.
There it is.
Bam. Again, just try to understand each part of it, okay? This is the circle area. And the second part is the area of the rectangle, okay? So again, we've done area of each one of those individually. Back in 7th grade, I know we did composite areas and stuff like that. So none of this is totally new, while surface area of a three-dimensional shape is, okay? Anyway, let's plug in what we know. So we have a height of 9.5 inches. This is height. We have a radius of 2.5 inches, okay? So remember, radius and diameter are two different things. Luckily, they gave us a radius. They didn't tell us what to use for pi, Mr. Knoll. So we're just going to leave it as pi, okay? If they want us to replace pi with a number like 3.14 or 22/7, they will tell us to do that. If they don't, guys, we're just going to leave it. Remember, pi is just a number.
Just a number.
Okay? So 2 pi r squared. R was 2.5, so we're going to put 2.5 in here, and we're going to square that number. Okay? Again, this is the area of the circles, right? And there's 2 of them. So we're going to do that. We'll work on the circle area first, then we'll work on the rectangular part, okay? 2.5 squared is 6.25. So this number turns into 6.25. Now, multiply that by 2. I'm going to get 12.5, and we're going to call this number 12.5 pi. Good to go. All right, second half is the rectangle, right? This is 2 pi. Again, the radius has not changed. It is still 2.5.
Still.
Okay? Again, we're finding the circumference. That's the 2 pi r. The height on 9.5. 9.5. Right? This says multiply 2 times pi times 2.5 times 9.5, right? We're just multiplying all of those numbers together. So 2 times 2.5 times another 9.5, I get 47.5. Again, pi. We haven't multiplied pi into this expression yet. That's okay. We're giving the answer in terms of pi. You can kind of think of it like a variable, guys. Okay? We need to add these two together. So I believe that should turn into 60.
The big 6-0.
Right? In just a few short years, Mr. Stayer will be 60. Okay? Mr. Philippi already there. So guys, my answer is 60 pi. So that would be 60 square inches. Okay? Beautiful. Again, a lot going on there in that example, right? Key for us to remember is if we have a formula, let's plug in what we know and use it. All right, let's see what we got here.
Ooh.
Yes.
Ice cream. I love ice cream.
Everybody loves ice cream. I'm going to turn these lights off, Mr. Earl, see if it's any better. Nope. There we go. Maybe, I felt like it was a little bit too dark. Okay.
He's back.
I'm back. Here we go. Draw the net of the cone to represent this so that we can find the area of each surface, okay? So again, cone, very popular shape. Here is our net. That, I believe, looks to be like a circle. Not sure what this is.
Piece of pizza.
Yeah, it's like a pizza slice. Sure. Okay. Hope they give us some handy formula to figure this out.
I bet you they will.
Because I know that we know how to find the area of a circle. Right? Now, the other part, maybe not so much. Okay? So the area of the circle, guys, and remember, we're finding surface area. I want to add this area and this area together to get surface area. So come up with a number here, add it to this one. Area of a circle. They did all that work right here, right? Area is pi times the radius squared. Is 1.5 a radius? Yes, it is, right? If they would have given me 3, that's the diameter. You have to divide it by 2. Okay? So there's their area for the circle. Now, the pizza shape. I don't even know. Does this have a technical name for it, Mr. Knoll? He's going to look that up. If it does, we'll figure it out. Anyway, here is our formula for this one. We do pi times the radius times the slant height. That is a little letter L there. That represents the slant height. Okay, so pi r L. Again, multiplying those 3 numbers together. Okay, so 1.5 still the radius. 6, right? The slant height is this length of the diagonal here. Okay? Multiply all that together. 9 times pi. Good to go. And there is approximately our area there. Once again, you've got to add these 2 numbers together. They're adding the area for this pizza-shaped thing and the circle. That's how they came up with that 35. Okay? So again, cones. We're only going to deal with 3 figures in Chapter 8. Cones, spheres, and cylinders. Okay? So let's take a look here at our next example. I know that one was fun. This one's even better. You know why it's even better, folks?
Video.
Because there's a bonus video. Just for you.
James is making a model of Earth.
Sphere. Told you
He
it was
has
coming.
enough blue paint to cover 500 square inches. How can James determine whether he can paint the entire sphere blue?
Paint the world blue. Here we go.
Draw a sphere to represent the model of Earth. A sphere is the set of all points in space that are the same distance from a center point.
There you go.
For this model, what should be the length of the radius of the sphere?
12 inches, right? Shouldn't it be? I mean, it says it over there on the world, 12 inches.
Nope.
Is Mr. No right? Is it not 12 inches?
Dang on right, I'm right.
No, yeah. Guys, 12, right? When we go from edge to edge, that's a diameter. When I go from edge to the center, that's a radius. So radius, divide that number by 2. That should be 6 is our radius. Mr. Knoll was right.
The radius is 1/2 of the diameter. The diameter of the globe is 12 inches. So the radius, r, of the sphere is 6 inches.
Sphere.
To find the surface area of the sphere, compare the sphere to an open cylinder.
Oh, boy.
An open cylinder is a cylinder that has no top or bottom surfaces.
They're going to
The
prove
surface
to us
area
what
of
the
an
formula
open
is,
cylinder
guys.
is equal to 2 times pi times the radius, r, times the height, h.
Mm-hmm.
An open cylinder with the same radius as a sphere and a height of 2r has the same surface area as the sphere. So, to find the surface area of the sphere, substitute 2r for h in the formula, and then simplify the expression. The result shows the formula for the surface area of a sphere,
There it is.
which is 4 times pi times the radius r squared.
There's our formula for that one. They're just proving
Now use
to
the
us.
formula to find the surface area of the model.
Okay?
Substitute 6
6
inches
was
for
our
the
radius,
radius,
remember that.
r, and simplify the expression. The result is that the surface area is slightly greater than 452 square inches.
Beautiful.
James has 500 square inches of blue paint,
Paint the
which is
world
greater
blue,
than
James.
the surface
That
area of
boy.
the model. So he
Yes.
can paint the entire surface of his model blue.
Okay. Way to go, James. Let's take a look at what we have to do here. This is also a bonus. We get 2 try-its for the price of 1 here. Okay. So the first one, guys, comes back to our example in example 2 that we had here in 8.1. Okay. What's the surface area of a cone? With a radius of 7 and a slant height of 9. So everybody draw your best cone. Here's my best cone there.
Nice job.
There it is. Again, let's label in what we know, guys. Nothing drives me crazy when you guys don't draw a picture in here, right? Like, I'm good at math, but I don't even like to do this without having a picture so I can visualize what dimensions go where, okay? So radius of 7, okay, so that's going to be this distance right here is 7, and I have a slant height of 9, so that means this dimension here is 9. Okay, that's all I really need. Remember, when we find a surface area of a cone, we find the area of the circle, and we add that to the area of the pizza pie shape, right? That was that pi r l. Okay? All right. Now, it's telling us to use this fraction 22/7 for pi. So we're going to replace, everywhere I see pi, I'm going to replace it with that number. Everywhere I see an r, I'm going to replace it with 7. Everywhere I see an L, I replace it with 9. We've done this all year long. So this is going to turn into 22/7 times the radius squared times 7 squared. Okay, we're going to figure out what number this is. Let's just do that right now. I have a feeling this is going to turn into a good number here. I'm not super good times, I'm going to say 49. This turns into 154. I was right. Okay? Again, now let's work on the second half. This is the pi times r times L. So same thing. Pi is that 22/7. The radius hasn't changed. The slant height is 9. Okay? So again, now we're going to multiply those by 7 and 9. I think we should get another good number here. 198 is what I get. Okay? Bam. Bam. Add those two together. And that is your surface area for the cone, right? This would be 352. We are in cubic feet. Okay? Beautiful. All right, I'll leave that up in case you want that. I'm going to get rid of my cone.
That was a nice job.
Yeah.
I have been searching. I cannot find a technical name for the curved
pizza pie shape?
shape of
Okay.
a cone.
Dang it. Okay.
I'm sad to report that.
Okay. Again, guys, so we're going to use a formula. We're going to write it out. So in the second problem, right, we're dealing with a sphere. Here is our sphere. It has a diameter of 2.7 inches. 2.7 inches is the diameter. They're telling us to use 3.14 this time, okay, for pi. So again, replace pi, replace r with those numbers, right? So 4 times 3.14 times, what is this, 2.7 squared? Okay, do you guys like that? No, you shouldn't. What's wrong with that? This is the most common 8th grade mistake.
Can't use 2.7.
I can't use 2.7. That's right, because this is a diameter. My formula involves a radius. Okay? So I need to cut 2.7 in half, divide it by 2. 1.35 is the number I want to use here, folks. Okay? 1.35 squared. Once you have this, it's literally nothing more, guys, than typing all of that into your calculating device. Okay? And making sure that everything looks good. 1.35 squared. Okay? I get approximately, I'm going to say 22.89. Okay? Cubic inches. I got a little bit of other stuff on there. Okay? Anyway, guys, there you go. So there's the beginning of Chapter 8. I feel like this is probably the hardest stuff that we're going to do all of Chapter 8. I think the rest of it gets a little bit easier. Anyway, tune into page 400 and whatever is next, 420, something like that.
420.
All right, for key concepts. See you.